Traditional camera controls for object inspection often require a combination of three separate camera tools: panning, zooming, and tumbling. Here you can see we use the left button for tumbling, middle button for panning, and the right button for zooming. We have developed a camera tool that combines these three operations that can be operated with a single button that we call HoverCam. As you can see, moving along the side of the cube, the camera automatically pans the model, keeping it normal to the view. When moving past the edge of the cube, the camera automatically turns to face the other side. Notice that the camera always stays a fixed distance from the surface of the model. On a cylinder, moving up or down rotates the cylinder always facing the camera. When we move to the end of the cylinder, the camera is rotated around to face the disc. Again, because the surface is flat, moving around simply pans the camera. On more complicated models such as this car, the model can be closely inspected from a fixed distance as the camera hovers around the object following the contour of the shape. Note that an otherwise complex camera motion path is followed with a very simple interaction. Here we see on the left the point of view of the HoverCam camera, and on the right you see a visualization of the algorithm depicting the two fields of view used to detect underlying surfaces. One field of view follows the surface, while a second field of view searches for obstacles in the direction of motion. In addition to moving around convex shapes, HoverCam can also turn in sharp corners. Here we see the obstacle field of view finding the approaching wall, helping to turn the camera. A critical design feature is the choice of the camera orientation determined by an up vector. Here you see a cube with the faces labeled, showing which way is up for a given face. As we move around the cube, HoverCam interpolates the up vector to adhere to the design of the up model. We have defined three procedural models for the up vector. With a global up vector, moving across a model of a globe will maintain the camera's orientation to always have the up vector point to the North Pole. If we use the local up model, the up vector always stays constant. Moving over the North Pole will not reorient the camera, causing the other side to seem upside down. We have shown HoverCam that intelligently combines panning, zooming, and tumbling into a single tool, ideal for tasks such as object inspection.